Can it not, does it have to have straight sides? Yes.
So what we're going to do is we're going to talk about today what polygons are. And so if you notice, the definition of a polygon is a closed figure in a plane. And so we have some examples of what polygons are and what are not polygons. And so if you notice a little bit about polygons, they're always composed of straight lines, no curves. Okay, the other thing is, notice there are no intersections like on the inside. Okay, you don't have something like this right here. And so anyway, a polygon, closed figure in a plane. It's many-sided, can be multiple sides, and so we're going to talk about classifications of polygons as well. Okay, and so a little bit about polygons. Notice we have the sides. Those are the outsides. Okay, and then we have the vertices. Okay, individually these are each called a vertex, but if you have a plural, it's vertices. Okay, and so in this figure I have 3 sides and 3 vertices. A little bit about consecutive. We have consecutive angles, which are angles right next to each other. And then you have consecutive vertices, vertices right next to each other. And then consecutive sides right next to each other. So consecutive, remember, just means next to each other. So here, we're going to classify them by sides. This is taken from your book. These are things you probably already know. If there's a few you don't know, you probably better write them down. We have a triangle, which is a 3-sided figure. Everybody should know that. Okay, a 4-sided figure is called a quadrilateral because quad, that prefix, means 4. Kind of like you have a quad and you go, riding around like in the sand or, things like that. That has 4 wheels. Also your quadriceps, your muscles, 4. So, quadrilateral, 4. You have a pentagon, which is 5. The pentagon at Washington, D.C. is 5 sides. Also, the pentathlon is 5 events. Hexagon, 6 sides. All right. You sometimes have that hexagon pizza, 6 sides. All right. Heptagon. Once again, the heptathlon, 7 events. Octagon is 8. Octagon is actually the stop sign. Octopus has 8 legs. Nonagon is 9. Decagon is 10. So then you have the men's decathlon, which is 10 events at the Olympics. Okay. 11 is the undecagon, and 12 is a dodecagon. Now anything above that, what we call that an n-gon. So if it would be like a 20-sided figure, we would call that a 20-gon. A 50-sided figure, a 50-gon. So basically the number would indicate how many sides it had. Pretty straightforward. So a little bit about how you name these figures. Pentagon A, B, C, D, E. Generally you try to name them in alphabetical order. This could also be named A, E, D, C, B if you're going around this way. Okay, but it's most accepted to try and go alphabetical order if that works. And then triangle ABC. Notice you can now use an abbreviation for a triangle. You don't have to write out the words triangle ABC. You can just put that little triangular symbol. Questions so far? All right, the diagonal of a polygon. Segment that connects 2 non-consecutive vertices. Now this is where some people kind of get confused. Okay, especially when we start getting to some of our bigger figures. Basically, how you figure out what diagonals are. So if I were to draw, let's just draw we'll draw a bigger one even, and I'll show you. Where do we got it? Right here. Okay, there we go. Okay, so how you draw diagonals is, say for example, I'm going to draw all the diagonals from this point. And so first of all, I go to this diagonal, or this vertex, sorry. I go to this vertex, but this one's right next to it, so this doesn't count. So I don't draw anything there. Because in fact, if I would try to draw it, it's going to be the edge of the shape. Right? So then I go to the next vertex, which is right here. I can connect those. I go to this vertex right here. I can connect these. Go to this vertex here. Connect those. What about this one? No, because when I connect it, it's going to actually be a side. So that's not a diagonal. Now, those aren't the only 3 diagonals, because I could draw all the diagonals then from this point. And you go around and do the same thing. I look at this vertex. Nope. This vertex. Yep. This vertex. Yep. And that vertex. Yep. When I get here, can't do it. So then you just work your way around. So then I start with this point. Can't go here, so then I can go here. Can go here. And I've already went here with the blue. So you see kind of how you work your way around? Now the interesting thing about the diagonals is they do form kind of a neat little shape. Okay, you can kind of see I'm only missing about 1 or 2 more. And then it would form kind of a star in there. So let's go ahead and look at convex and concave. These are 2 definitions. A convex polygon, all diagonals are inside. A concave polygon, 1 or more diagonals are outside. That's one definition. But once you look at that, I want you to look at each of the figures. I want you to look at the convex and the concave. And I want you to tell me another way that you could tell the difference between the 2. So I just want you to look at those. And tell me just by observation, you wouldn't even have to draw diagonals in. How could you distinguish the 2?
Duct tape. That's what I'm going to try next.
I thought you meant.
You can do Sarah's little penguins. Sarah's penguin duct tape.
Yeah.
That's awesome.
All right, so does anybody have a way? Anybody just have a visual way?
Wait, what?
Yeah.
Like where the lines would go inside the figure rather than outside.
So basically, when we think about this, we've got concave, cave. Like I said, I always like to look at the figures. Where does it look like you've got a cave? Doesn't that kind of look like you got a cave, kind of something that'll go inside? Okay. I know this one you kind of have to stretch. It's like it'd be a short cave, but it would work. And then you have something like this. So when you see something that kind of indents that would make like a cave, that's how you can distinguish the 2, just visually. All right, look at all these. These don't have any of those little hidden places, caves. Okay, so that's a way that you can kind of distinguish the 2. If you want to use the diagonals, great, you can do that as well. Okay, now, one of the things about this, if polygons are congruent, so that means if we know that the shapes are congruent, all the sides and angles have to be the same. Same, if all the sides and angles are the same, then we know the polygons are congruent. If I look at this, okay, CAMP is congruent to SITE. What that means is that C has to be congruent to S because the order is important how you write these. Order is important. You have to get that down. A is congruent to I. Those 2 are partnered up since they are the second letter. They match, they are the same. Okay? M is the same as T. Those match up, and P is the same as E. So order is extremely important on these, and that's what we're going to look at. So which polygon is congruent to A, B, C, D, E? So I'm going to have you go ahead and take the expressions real quick. Okay, I'm going to have you take the expressions real quick. I'm going to get you logged in.